Okay, this is part 3. We're looking at the general rule of addition when it comes to probability. And this one we've got visits to the doctor. So a national ambulatory medical care survey administered by the Center of Disease Control found that the probability a randomly selected patient visited the doctor for blood pressure check is 0.593. The probability a randomly selected patient visited the doctor for a urine analysis is 0.064. Can we compute the probability of randomly selecting a patient who has visited the doctor for a blood check or a urine analysis by adding these probabilities, why or why not? So in this case, we basically want to know what's the probability of getting blood pressure check or a urine analysis, and this is going to be the probability of getting your blood pressure checked plus the probability of getting your urine checked minus the probability of getting blood pressure and having a urine analysis. And the thing that's missing here, we can't find out this probability because we don't know anything about those who come for both. So we cannot simply just add these together because we don't know that they're disjoint. So we don't have sufficient information in order to answer this question here. So again, that's the big thing between disjoint and not disjoint. We don't have anything to show that they are disjoint, and so we cannot making that assumption would probably not lead us down a very good path as far as the numbers are concerned. Okay, lastly, social media. Harris Interactive conducted a survey in which they asked adults, American adults, 18 years and older, whether they use social media, so Facebook, Twitter, and so on. Regularly, the following table is based off of those survey results. So, for example, use social media, those 18 to 34, there's 117. This is called a two-way table. There were 338 who used social media total out of 530 total participants. So it's just a way to look and read these. So, and then the number of people ages 35 to 44 is 125. So that's kind of look at the rows and columns. Okay, so in this one, if an adult is randomly selected, what is the probability he or she uses social media? Well, we would look at all the people who use social media, which is 338, divided it by the total number of people, which is 530. And so in part A, you would just take 338 divided by 530, and this will give us about 0.638. Okay. So then the next one, if an adult American is randomly selected, what is the probability that he or she is 45 to 54 years of age? So 45 to 54 is right here, so there's 140 of those people out of 530. So we'll take 140 out of 530. Okay, that does reduce down to 14/53, or 0.264. So 26.4% are between the ages of 45 and 54. Okay, part C. If an American adult is randomly selected, what is the probability that he or she is 35 to 44 years old? So they are a 35 to 44-year-old social media user. So this is basically saying what's the probability that they're 35 to 44 and they use social media. And so what we can do, this is the nice thing about the two-way table, is we're going to look and we're going to see, okay, so those that are 35 to 44, that's this column. And those that use social media is this row, and their intersection is right here. There are 89 users. So then we would take 89 of those users and divide it by, or those individuals, and divide it by the total 530 people. And that would give us 0.168. So that is the number, or the probability of someone being 35 to 44 and they're a social media user. Okay, and lastly, part D. Okay, what is the probability that a user is 35 to 44 years old, or, so there's a keyword there, or uses social media? So when we're looking at the or, this will need to add the probability that they're 35 to 44 plus probability that they use social media, and then we have to subtract the probability that they are 35 to 44, and I'll just put social media for short. Okay, so we found the probability that someone is a social media user, or excuse me, 35 to 44, or no, we found 45 to 54, so this would be 125 out of 530. So that's the probability that someone's 35 to 44, plus the social media user, that was 338 out of 530. Okay, because again, you had 338 total social media users out of the 530, and then minus 89 out of 530. That was what we found up here in part C. So then when I add all those together, I get 374 out of 530, which is roughly 0.706 or 70.6%. So that's the probability that someone is 35 to 44 years old or uses social media based off of this data that has been gathered by Harris Interactive. So that's just a look at the addition rule. And again, this last one we did was called a two-way table. And if you have any questions, let me know, but I appreciate your time and joining me for this lesson.